Hi guys, this is group reporting of algorithms, and are you ready to listen? Okay, listen and study together. What are algorithms? Uh, let's go, and please watching the video. Do not skip and more learning.
What is a
Thank you.
search algorithm? Search algorithm is a step-by-step technique for locating certain data within a set of data. It is regarded as a fundamental computer operation. When looking for data in computer science, the difference between a fast application and a slower one is often determined by the search method. Exponential search. Exponential search, also known as finger search, looks for an element in a sorted array by jumping two I elements in each iterations, where I is the loop control variable's value, and the checking if the search element is present between the previous and current jumps. Complexity worst case. O log n. The algorithm is named that way because of the name, not because of complexity. The algorithm's name comes from the fact that it jumps elements with step equal to exponent of 2. Steps 1. Jump the array elements at a time searching for the condition array. Steps 2. Do a binary search between array. And this is the example on C++. So, search linked list versus array. Assume you need to find the specific elements in an assorted linked list and arrays. In that instant, a linear search is required. Remember unsorted. It will take O(n) time to perform a linear search for an element in either data and structure. Now, if you have a sorted linked list and array, you can still search in the both the data and structure in O log n time using binary search, although it will be a bit tedious to code while using linked list. When insertion is a frequent operation, linked lists are frequently favored over arrays because only a pointer changes. It's easier to insert linked lists. However, if you want to insert in the middle or beginning of an array, you must relocate all the elements after the one you want to insert. Another place where you should use linked lists is where size is uncertain. You don't know the size when you are starting out because arrays have fixed size. Array do provide a few advantages over linked lists: random access, less memory as compared to linked lists. Arrays have better cache locality, thus providing better performance. It completely depends on the use case for whether arrays or linked lists are better. Suppose you are given a list or an array of items. You are searching for a particular items. How do you do that? Find the number 13 in the given list. You just look at the list and there it.
So how long would the linear search take? In the best case scenario, you might get lucky and find the object you're seeking for the array's first place. In the worst case scenario, you'd you'd have go through each and every time until you find the item for the last position, and that is it's that in array. As a result, in the linear search completely is zero. The complexity would be zero if the element is found located in the first memory block. The code for the linear search function in the JavaScript is shown below. This function returns the position of the item we are looking for in the array. If the item is not present in the array, the function will return. What if you are searching the multiple occurrences of an element? For example, you want to see how many 5s are in array. This array has 3 occurrences of 5s and we want to return the indexes. This is called global linear search. You will need to adjust your code to return an array of the index points at which it finds the target element. When you find an index element that matches your target, the index point will be added in the results array. If it doesn't match, the code will continue to move on the next element in the array by adding 1 to the counter. While linear search is not efficient, there is no doubt that linear search is simple, but because it compares each element one by one, it is time-consuming and hence not very efficient. If we have to find a number from, say, 1 million numbers and number is at the last location, linear search technique would become quite tedious. So, also, learn about binary search, exponential search, etc., which are much more efficient than linear search. Binary search, by dividing the search interval in half repeatedly. A binary search locates an item assorted in an array. How do you search a name in telephone directory? One option is to start from the first page browser through the phone book, one name and at a time, until we locate what we're looking for. However, that would be a very consuming and inefficient method of searching, because we know that the name in the phone book are sorted alphabetically. We would probably work along the following steps.
Good day to everyone. I'm Louis Angelo F. Calingo and I'm going to start my report on open the middle page of the phone book. If it has the name we are looking for, we are done. Otherwise, throw away the half of the phone book that does not contain the name. Repeat until you find the name or there are no more pages left in the phone book. Time complexity. As we dispose of one part of the search case during every step of binary search and perform the search operation on the other half, this results in a worst case time complexity of 0 close and open parenthesis log 2n close and open parenthesis. The best case occurs when the element to be found in the middle of the list. The best case time complexity is 0 close and open parenthesis 1 close and open parenthesis. Space complexity. Binary search takes constant or O close and open parenthesis 1 close and open parenthesis. Space meaning that we don't do anything input size relate variable defining. For small sets, linear search is better, but it's in larger ones it is way more efficient to be used binary search. In detail, how many times can you divide n by 2 until you have 1? This essentially saying do a binary search half the element until you found it. In a formula, this would be this. So this will be our formula. Let's go to the next one. So, the process of the formula. This means you can divide log n times until you have everything divided, which means you have to divide log n, do the binary search step until you found your element. So, the binary search algorithm takes a divided and conquer approach where the array is continuously divided until that item is found or until there are no more elements left for checking. Hence, this algorithm can be defined recursively to generate an elegant solution. And the two base cases for recursion would be no more elements left in the array. Item is found. So this will be our formula. So the power of binary search in data system B plus 3. Binary search tree are very powerful because of their O login or login. Search times seconds to the hash map data structure, which use a hashing key to search for data in 0 or 1. It is important to understand how the log-n runs times comes from the height of the binary search tree. If each node split into two nodes binary, then the depth of the tree is log n base 2. In order to improve this speed in data system, we use B plus 3 because they have a larger branching factor and therefore more height. So that's all for my report. Moving on.
Listening, and I hope you learning something from the group report. Thank you very much and God bless.